Tell us a little bit about what we are doing in offshore wind and what is the potential there.
Well, compared to land-based, the windmills that we are talking about, wind farms, wind turbines, the advantage of actually going out in the offshore is that it's a continuous flow of wind, number one. Irrespective of season, I think we are able to tap more energy than on the mainland. I think the mainland, you would be knowing there are only specific locations where we can tap this wind energy. And similarly, I think there are some locations have already been identified by Ministry of New and Renewable Energy. I think another standalone ministry or sister ministry that that works on estimating resource assessment of the how much is wind power potential in the offshore environment. But when it comes to tapping of this energy, there is a technological intervention required. You need not only the right turbine, but you also need the right substructure that supports the turbine.
Okay.
So in the mainland, I think it's very simple. You bring a turbine, you bring a mast, you anchor it with a foundation, simple as that. But when it goes to offshore environment, the depth decides what type of substructure it should be to support the turbine. And then as you go deeper, like beyond 100 meters or so, for example, water depth in the offshore environment, then the challenges are even more than that, because you'll have 100 meters of water column, you have a lot of wave dynamics and other current dynamics and so on. So that makes the engineering totally different ballgame altogether. And to be honest with you and also to the audience, that right now we are still in baby steps in terms of the engineering and probably the installation part I'm talking about. Even though the engineering might have grown enough actually within the country, but the implementation is another big challenge. So you need to fabricate the substructures in parts, mobilize them to place where you are supposed to install them, including the turbines. We are talking about turbines of bare minimum 100 meter diameter and beyond, 200 meters and things like that. So it's a massive.
So these are bigger than land-based turbines.
That's the idea, I think. So when you have more wind potential, you should bring more big turbines to tap. I'm talking about 5 megawatts and so on, and beyond that. So without which I think it is going to be economically not so feasible. So bigger is better. And obviously we need vessels that can take these huge turbines, and then you also need vessels that can take the substructure and install there. I think in the offshore environment it is even more challenging. You have to stay in a place first of all, and you have the waves and other dynamics are actually making your vessels which carries this always in the 6 degrees of freedom motion, right? So you need vessels of highly controlled to their dynamic positions in a way that it understands the waves and gives a feedback system that the ship stays almost as if you are standing on a mainland. So you can imagine now what amount of technology has to go in, even the designing of the ship itself, first of all.
Very actively controlled to be stable.
We call it as dynamic positioning system.
Sure.
So DP system. So those dynamic position system has to be really very effective, that I can confidently raise the substructure and then place it on the seabed and then install it properly. And then you will be installing the turbine and so on and so forth.